Okay, so hi there. Sorry, I was muted. So, um, it says given the following function, f of x equals 4x cubed minus 3x, find the following. So we want to find the zeros, the critical points, and the relative extrema, right? So, um, in other words, the maximum or minimum. Um, so, um, here, we want to first, we're going to go ahead and write the function down. So f of x equals 4x cubed minus 3x, right? Um, and so, um, and so what we're going to do is we're going to go ahead and find the derivative, right? Actually, first we're going to find the zeros. So 0 equals 4x cubed minus 3x. And so, here we're gonna solve this by factoring. So we're gonna take out an x from this. So we have we can factor out an x here. So we're gonna end up with 0 equals x, and then times 4x squared minus 3, right? And you can always check it by distributive property to make sure that you factored it correctly. And then what we're going to do is the zero product property. So we have x equals 0, or 4x squared minus 3 equals 0. And so then what we're going to do is we're going to go ahead and add 3 to both sides. So here we have 4x squared equals 3, and then we're going to go ahead and divide by 4. So then it's going to be x squared equals 3/4, and then we're going to take the square roots, right? So x equals plus or minus the square root of 3/4. You can simplify this and say that this is x equals plus or minus the square root of 3 over the square root of 4, which is plus or minus the square root of 3 over 2. So it would be x equals a negative square root of 3 over 2, and square root of 3 over 2, as well as x equals 0 for the zeros. So these are the zeros of the polynomial function. Now, what we want to do next here is we want to go ahead and find the critical points. So to find the critical points, we're going to have to take the derivative. So f of x, again, is 4x cubed. I think it was 4x cubed minus 3x, right? Yeah, so 4x cubed minus 3x. And actually, give me a second. I just want to make sure I have that correct. Yeah, so 4x cubed minus 3x. And so then the derivative f prime of x will equal 12x squared minus 3. So it's just power rule, right? And then from here, we're going to set this equal to 0. So 12x squared minus 3 equals 0. And so then we're going to go ahead and add 3 to both sides. This is going to give me 12x squared equals 3. And so then we're going to go ahead and divide by 12 here. So then we'll end up with x squared equals 312, or I'm sorry, x squared equals, and we're going to divide by 3 on top and bottom here to reduce it, 1 over 4. So then when we take the square root, we're going to have x equals plus or minus the square root of 1 over the square root of 4, right? Because we take the square root of the top and the bottom, just like we did with the original function when we solve for x. So we have plus or minus 1 over 2. So the critical points, or the critical points are x equals plus or minus 1 over 2. Now, as for the maximum and minimum, maximum slash minimum, we want to go ahead and do a number line, and we're going to put our critical points or critical x values here. So -1/2 as well as 1/2. So we're going to test the following intervals for increase and decrease. And then from there, we'll determine where, from there we'll determine where the maximum and minimum are. So we're going to test the interval from -infinity to -1/2, comma, -1/2 to 1/2, and then comma, 1/2 to infinity. Now, we're going to test, so for this one, we're going to test x equals, let's do -2, okay? So when we do that, the derivative, again, f prime of x is 12x squared minus 3. So f prime of -2 is equal to 12 times -2 squared minus 3. This is 12 times 4 minus 3, which is 48 minus 3, so it's positive. So that means it's increasing in this interval. So here's -infinity. Okay, so it's increasing. And then from -1/2 to 1/2, we're going to go ahead and do the derivative f prime of 0 at x equals 0. So we can do it at x equals 0. So f prime of 0 is going to be -3, because if you plug in 0 to this, you will get -3 since it's 0 minus 3. So it'll be negative here. So it's decreasing here. And then from 1/2 to infinity, we're just going to do f prime of, let's do f prime of 1. So this is 1/2 infinity. This is -1/2 to 1/2. And this was -infinity to -1/2. Just making it very clear, right? Sorry if it's taking me a while to do this problem. It's pretty long. So then finally, we're just going to go ahead and do 12 times 1 squared minus 3. So that's going to be 12 minus 3, which is 9, so it's positive. Okay, so now we know it goes increasing and then decreasing and then increasing again. So it's like, it's from -infinity to -1/2. It's increasing, and then from -1/2 to 1/2, it's decreasing. So it goes like this. And then from 1/2 to infinity, it's increasing again. So so it goes from decreasing to increasing again. So it really goes like this. And again, this is at -1/2, and then it goes decreasing and then increasing. So this will be at, this critical point would be at 1/2. I hope that makes sense, right? Because if you see it kind of goes, you can kind of see how it kind of goes back to, from decreasing to increasing. So our maximum is at y equals -1/2. If we calculate that to find the actual point at which the maximum occurs, we get, give me a second. So 4 times -1/2 cubed minus 3 times -1/2 is 1. So we have a maximum at negative, I'm sorry, this should be x equals -1/2, excuse me, not y. At -1/2, comma 1, and then a minimum point at the following. So it's gonna be so when I do 1/2, 4 times 1/2, and then cubed minus 3 times 1/2, I will get -1. So a minimum point at 1/2, comma -1. So these are my maximum and minimum points, and the maximum and minimum values are at x equals -1/2, and as well as x equals, so the minimum is at x equals 1/2. I'm sorry if this is a long problem, but that is how we do this problem. I might have added more than what I needed to, but I hope that helps. If you have questions, you can book a session with me, but I do hope that helps, and thank you for watching. Bye-bye.